Good day, everyone, and welcome to our webinar on common issues with SEND data submitted for safety pharmacology studies. CDER's Office of Computational Science will provide updates on the KickStart service, now known as the OCS Nonclinical Services, and discuss updated data quality information focusing on submitted data, study data, conformant to the standard exchange for non-clinical data, also known as SEN, Implementation Guide version 13.1. My name is Ray Ford, and I work with the Small Business Industry Assistance Program, also known as SBIA, which resides in CDER's Office of Communications, Division of Drug Information. I'll serve as your host for today's event. This slide provides QR codes for our social media avenues. You can scan them now with your phones and be taken to the appropriate platform. Okay, let's turn to some logistics now in our ongoing environment. This event is being provided as a 100% virtual. As such, there may be some internet issues, but please bear with us. If in fact we encounter those, we'll try to get them resolved as quickly as possible. Speaking of tech issues, the first slides provides links to our one-stop shop for answers to your technical questions, for downloading files, accessing the survey link to obtain the certificate of attendance, and much more. That's the same page you used this afternoon for your online access to the event, so please bookmark that page. If you have any technical questions, please check there first, and you'll most likely find the answer. We invite you to submit your questions to us prior to and during the vibrant and productive Q&A segment, which is crucial to these events. We'll answer as many questions as time allows, and when you do submit your question, please identify the individual presenter by prefacing your question with the speaker's name as shown here at Jesse. Also, during the presentations, there's a link to the right side of the pod where you see the speaker's headshot and it says download the presentation. Note that this link is only active during the real-time presentation. There's also a link to the speaker evaluation. We encourage you to take time to complete the evaluation as your feedback is much appreciated by individual speakers. In addition to the speaker evaluation, we have our final evaluation. Upon completion of this survey, an attendee can then download a certificate of attendance which may be used in support of RAP-SOCRA, ACRP, and SQA credits. The trick is that the certificate must be downloaded immediately after completing the survey. Otherwise, this opportunity is lost. Even if you do not want or need the certificate, please take a few minutes to complete the final evaluation as your feedback will help guide the design of our future events. Note that both the evaluation and the certificate of attendance are only available for 2 weeks, which means the deadline is November the 30th. The survey link will be posted on our one-stop shop page this afternoon. As a reminder, all the presentations are being recorded. It'll take us a week or two to process the recordings, but you soon will be able to access them from SBI's webpage. And I hope you already have that bookmarked, and that's fda.gov/CDER-SBIA. To simplify things, SBIA will send one email to all Adobe attendees later today post-event. The email SBIA sends will have information on the evaluation link. We'd like to take this opportunity to remind you of some upcoming events on November the 28th. Join us for a webinar on Toward Global IDMP Implementation, a focus on global use cases. Join us on December the 6th and 7th for our FDA Clinical Investigator Training course. On December the 12th and 13th, we're having webinars on navigating complex waters, a deep dive into FDA drug interaction guidances and resources, and finally on February the 13th through the 15th, 2024, we're providing a joint US FDA, MHRA, UK, Health Canada Good Clinical Practice and Pharmacovigilance Compliance Workshop. Now we have a special announcement to make on enhancing adoption of innovative clinical trial approaches to understand the state of innovation in clinical trial design and conduct. FDA is asking for perspectives via comments to our public document, and that document number is FDA-2023-N-4489 by April the 19th of 2024, and or participation in the public workshop hosted in partnership with the Duke Margolis Center for Health Policy on March the 19th and 20th, 2024. For more information, please contact Dr. Kevin Bugan at the provided email address you see here on the slide. Now, to start our presentations, it's my pleasure to welcome your presenters for this webinar. First, we welcome Jesse Anderson, Team Lead Services Team, Division of Regulatory Review and Research, Office of Computational Science, and the Office of Translational Sciences, CDER. Presenting next is Dr. Benita Dharmaraj, Project Manager, OCS Nonclinical Services, Division of Regulatory Review and Research, Office of Computational Science and OTS, and our final presenter is Jennifer Feldmann, OCS Contractor, SEND Subject Matter Expert in the Office of Computational Science, OTS. Please join me now to welcome our first presenter, Jesse Anderson.
Hello, everyone. Thank you for attending since the SEND standard became required for Benita Dharmaraj and Jennifer Feldmann, and we are here to talk with you all today about updates to the service formerly known as KickStart, as well as common issues with SEND data submitted for safety pharmacology studies. For those familiar with the CDER standards, these would be studies that are conformant with SENDIG version 3.1. For today's agenda, I'm going to provide some background. What is the Office of Computational Science? Where do we sit within CDER? Also, where have we been since the SEND standard became required for INDs in December 2017? Benita will talk with you about updates to our service, the OCS Nonclinical Services, since the last time we discussed this with industry. Finally, we will move on to Jen, who will talk about common data issues we see for safety pharmacology studies, which are conformant to SENDIG version 3.1. First, I will provide some background on who we are and where we've been. Here is the CDER organization chart. You can see a variety of offices underneath CDER with a little red box circling around the Office of Translational Sciences, or OTS. The Office of Computational Science, or OCS, sits underneath OTS. We support multiple offices around the center for various review needs. We also interact with other offices within the center on various initiatives that we will not specifically cover in this call today. Drilling farther down into the OCS organization, we are split into two divisions. Benita and I are in the Division of Regulatory Review and Research and are the forward-facing arm of the office. This division provides services and training to reviewers in support of their regulatory reviews. Additionally, this division serves as a liaison between the reviewer community and tool developers, ensuring that each group understands each other and promotes efficiency in tool development and use. The Division of Tools, Technology, and Innovation provides the computer science and tooling expertise to build and refine tools that may be used for regulatory review. This division also provides the technical expertise to interface with other offices around the center to connect these tools such that reviewers can easily access them. The overall mission of OCS is to provide CDER reviewers with solutions that improve the scientific review process by integrating data, tools, and training. Our vision is to drive modernization of CDER's scientific review process with the implementation of tools, services, and training to enable reviewers to apply their expertise to information rather than the data itself. As you may recall, SENDIG version 3.0 became required for studies that started on or after December 17, 2017 for IND submissions. In response to this, OCS created the KickStart service. This service was offered to all PharmTox reviewers for applications that contained SEND data. The service consisted of a pre-KickStart training, a data fitness assessment, and exploratory session. The pre-KickStart session discussed the SEND standard, the NSDRG, the define file, and FDA tool features. The service itself covered a data fitness assessment that provided a sponsor report to provide industry feedback on their data and detailed any issues that would impact the reviewer's use of the data. The team showed the reviewers how to explore study data using FDA tools and how to produce tables and graphs that would be placed directly into the review. Finally, the team produced a set of key analysis tables and graphs. Now that we are well beyond the initial stage of requiring SEND, the team incorporated numerous changes to the services intended to allow reviewers to more quickly and readily use their SEND dataset package as part of their reviews. I will now turn this over to Benita, who will talk more about how we did this with the revamped OCS Nonclinical Services.
Thank you, Jesse. Hi, I am Benita Dharmaraj. I am the Project Manager for OCS Nonclinical Services. Today, I will provide an overview of the OCS Nonclinical Services, formerly known as the KickStart services. The vision for OCS Nonclinical Services is to provide CDER non-clinical review teams with a collection of services that enable an effective evaluation of a new drug or biologic application using submitted electronic data. These services include an introduction to electronic non-clinical data, a tutorial of key functions of analytical tools, different levels of fitness assessment for the submitted electronic data, and an introduction to data analyses and creation of outputs. The goal of this is to provide this service early in the submission review process, giving non-clinical study reviewers a better understanding of their data and the tools available to them for review. The OCS non-clinical services are broken into tiers. The 3 tiers include 2 proactive services and 1 reviewer request-based service. Tier 1A, Proactive Preliminary Data Fitness Assessment. In this service, we provide data issues that impacts reviewability, which are highlighted and presented to the reviewer, and when possible, workarounds are described, maximizing the usability of study data. Usability provides a way for FDA to understand what common issues are in the submissions and communicate those back to industry when applicable. Tier 1B, Proactive Visualization Service. Visualizations can be used as part of the reviewer's final template and gives them a different way to look at the data beyond how it's been formatted in the study report tables. Any safety issues that previously went unnoticed are brought up early in the drug application and approval process, giving sponsors a chance to address and consider the issues. Tier 2, Request-Based Service. This service is for reviewers that generates a deeper evaluation of data while offering opportunities for training and analysis support. This provides reviewers with an on-request service option that is much closer to the traditional model of KickStart, with a focus on training and explaining how SEND can be applied to review. As part of this service, we include a deep data quality analysis, allow reviewers to learn at their own pace, and act as a refresher for reviewers who have received training in the past. There are various training opportunities for PharmTox reviewers, one of which is the OCS Tier 2 service, For the first Tier 2 service, we provide reviewers with the capability to create graphs, tables, and visualizations of SEND data, explore study data in dose group, and also in individual animals. We drill down to inspect data for individual animals or small groups of interest. This chart provides a high-level overview of the various tools and services reviewers can use as part of their review. This includes receiving study data, scheduling sessions, performing analyses, and preparing outputs, conducting sessions, and providing follow-up as needed. One area I'd like to highlight is the data fitness assessment, which includes analyzing our findings from those which help us identify what are the common data quality issues are, which we report back in SBIA webinars, SEND face-to-face meetings, and other industry communication. I want to provide a high-level overview of the various divisions we provide non-clinical services. The pie chart shows the heavy uptake in SEND usage across FDA non-clinical divisions. This graph tells us that the Division of Hematology, Oncology, Toxicology sees a heavy SEND usage, along with the Division of Pharm Tox for Immunology and Inflammation, and the Division of Pharmacology, Toxicology, Cardiology, Hematology, Endocrinology, and Nephrology. The graph on the right simply shows that our service mainly only deals with original INDs. Unless requested by the reviewer, we have minimal BLAs, NDAs, or non-original INDs. I would like to provide a high-level overview of the non-clinical services by tier and fiscal year. In the first chart in red, Tier 1A, Preliminary Data Quality Assessment Services, in fiscal year 22, we had 166 services. In fiscal year 23, we had 186. In the blue chart, Tier 1B, Data Visualization Assistance, in fiscal year 22, we had 24 services. In fiscal year 23, we had 8 services. The drop in services was due to the Tier 1B was modified to include changes as requested by reviewer feedback. In the black chart, Tier 2, SEND Tool Walkthrough and Comprehensive Data Quality Assessment, fiscal year 22, we had 7 services. In fiscal year 23, we had 16. FDA saw a significant increase in the number of studies containing SEND datasets over the past 5 years. Complete and correct SEND datasets are critical for seamless, confident use of SEND datasets by FDA reviewers. Some common issues in SEND datasets can complicate or even prevent FDA reviewers' use of these SEND datasets. OCS Nonclinical team offers tiered assistance to PharmTox reviewers to provide the most appropriate level of support for reviewers' SEND experience to allow them to maximize the submitted data. Supporting services include SEND data quality assessment, assistance with generating safety analysis visualizations, one-on-one SEND analysis tool walkthroughs, issue diagnosis and resolution for low data to SEND analysis tools. Next, Jennifer Feldmann will be discussing common issues with SEND data submitted for safety pharmacology studies.
Thank you, Benita. Now we're going to go into some of the nuts and bolts of SEND for safety pharmacology studies. FDA CDER has been supporting SENDIG 3.1 for more than 6 years and now receives about 200 crossover design safety pharmacology studies per year. During the time that CDER has been supporting the standard, OCS has been providing services to the reviewer community to help them use those SEND data sets in their review. And during that time, we have seen quite a number of errors come through in the SEND data sets that have affected the reviewer's ability to use the SEND data sets. So for this presentation, we did a more systematic assessment of SEND data sets for safety pharmacology studies to be able to understand specifically what the problems are in the data sets, so that we could present them and hopefully receive better data sets in the future. So in our assessment, we selected 24 cardiovascular safety pharmacology studies that had been received at FDA CDER. We selected one study per test facility company. The idea here is to maximize the potential for variability in the implementation of SEND. We selected the most recent studies based on study start, so that we were hopefully assessing the implementation that was in kind of the most current SOPs or the most current thinking at each company. We focused our assessment on the Latin Square or crossover design study and the portions of SENDIG 3.1 that we thought would be affected most by that study design. So we looked at some trial summary information, some exposure information, and also, of course, the findings domains, particularly baseline flags, timing variables, and the results themselves. So this is the breakdown of the studies that we selected for our assessment. They were submitted between August of 2022 and August of 2023. They had started between February of 23 and October of 21. Most of the studies had been started in 2022, as you can see in the chart to the bottom right. The studies themselves were all quite similar. They all had 4 dose levels. Many of them were male only, but some did have both males and females. Most were oral gavage with a few other routes included. Most had 1 treatment per dose day, but there were 3 studies that had 2 treatments. I'm sorry, I should say 2 doses. The doses were about 6 hours apart on those 3 studies. Most of the studies had 4 animals per sex, and most of the studies had a 24-hour post-dose assessment period with a few different assessment periods included in other studies. And in the chart up to the right, you can also see that the majority of the studies were performed in the US or in China, about equal split between those two, but we did include studies from Japan, France, Italy, and India in this assessment. So the first part of the assessment was to see if the SEND data sets could be used in a review by FDA tools. FDA currently uses 2 tools for analysis of the SEND data sets. Both of the tools have both tabular and graphic representations of the summary data, but each tool uses a slightly different method of identifying the dose levels and the time points relative to dose for summarization of the findings. So we looked at the data sets that we selected for assessment. In both of the tools, we looked at tabular outputs and graphical outputs. And what we found, the summary is over to the right. 11 of the studies of the 24 could be used equally well in either tool. 8 of those 24 could only be used by one tool or another, and 5 of the studies couldn't be used in either tool. And on the slide here, I've listed specifically the issues that we found that impacted the ability to use SEND in the tools. I'm not going to go through them here in detail because in each slide subsequently, I will talk about the issues that we found in much more detail. But this slide is intended really just to summarize them. Primarily the issues were around element definition, definition of the dosing day or date, and definitions of time points. In addition to issues that affected the use of SEND in the tools for analysis, when we did the review of SEND, we also noticed other problems that didn't necessarily affect its use. So SEND has lots and lots of variables, and not all are used in FDA tools for any part of the analysis, but are of course available for reviewing. So again, I'm not going to list these out as I describe them, but they're here particularly for summarization so that you can refer back to them at a later date. And these in particular were kind of all over the map. There were all kinds of different issues identified. And one thing we did as part of the analysis as well is that we then looked to SEND. We looked at the SEND IG and said, so why do we think that some of these problems are occurring? Are there specific ambiguities? Are there errors in the standard? What is kind of driving the inconsistencies and the errors that we're seeing in the SEND data sets that we're receiving? And we did find a few of those where we think that the SEND standard itself could be either tightened or that people submitting could be a little clearer about what they're doing as part of the implementation. And so again, I'll include those items in later slides as well with more detail. All right, let's look at some of the issues that we identified in the trial summary. All but one of the studies that we assessed correctly identified the study as safety pharmacology as the category, it's SP, and as included cardiovascular pharmacology as all or part of the study type. We did have one study that came through as a tox study, repeat dose toxicity. Also for the study design, S-design, all of the studies were identified either as Latin square or as crossover. And as you can see in the definition of the controlled terminology in the gray box at the bottom of the screen, since the Latin square is defined as a type of crossover, I suppose either are fine, and all of the FDA tools will use either of those values to switch over to the different type of analysis that is needed for these studies. Okay, let me go back to study category for just a minute. 10 of the studies that we assessed were combined cardiovascular and respiratory safety pharmacology studies. And the SENDIG 3.1 for study category states that the most appropriate single value, as defined by the sponsor, should be included for trial summary purposes. So of those 10 combined studies, 7 followed that instruction in the SENDIG and had a single value of cardiovascular pharmacology. However, 2 of the studies had a second record for respiratory pharmacology, and 1 study used a single record with both controlled terms, comma separated. So this illustrates some problems with that particular instruction in the SENDIG. This does not cause any particular issue in FDA tools, but it was an inconsistency that we did see. Now let's look at how elements were used on these studies. In 21 of the 24 studies, there was 1 treatment element per dose level defined. And you can see in the subject element, the SE example over to the right, the element variable included the dose level and the units. In some cases, there was some additional information about the treatment, such as test article name, dose frequency, etc. Then in 13 of those 21 studies, there was additional elements defined for the washout or the rest period in between the treatments. And in the SENDIG, it appears that either of those are acceptable definitions of the elements, and both of these are usable in the FDA tools. The 3 studies that didn't have that definition of the element, in one study, there was one element that covered everything. So just one element, regardless of the dose levels, regardless of the order of the dose levels. And that study, the way that was defined, there was no way to use the subject elements to identify the dose given. One of the studies also then had one element per dose sequence, essentially an element per animal. And then that one element was included in one arm or one set. That too, there was no way in the element definition then to identify the dose level there. The one study kind of went to the other end of the spectrum. There was one element per dose level per animal. So an animal received control, it had an element, a different animal receiving control actually used a different element. So in that case, for animals, for dose levels, there ended up being 16 elements. That didn't allow the dose levels to be aligned across animals, and that study wasn't usable. There was one study that did have the correct treatment element definitions as I described in the previous slide. It had a little quirk in it that the males and females were included in different sets, even though they were in the same treatment sequence, and the set label and the set name were different. This caused some issues, and we did have to use a feature of the tool to override that so that that study could be used. There should always be, in any study, a one-to-one relationship between a set label and a set name. Most of the studies, in terms of the arms and the sets, used information about the sequence of the doses given in the labels. And that made it very easy to see the intent of the arm, the intent of the set organization. But in some of the studies, there was 3, there was nothing but a number, 1, 2, 3, 4 for the sets, 1, 2, 3, 4 for the arms. It is, of course, possible to go into the arms to look at the elements that were included, but it was certainly nice to have the definition of the treatment sequence in the arm, so it was easy to spot. And then one study had animal numbers in the labels, and since each of the animals did receive a different sequence, it's kind of hard to argue with that approach. It was just a difference in how that sponsor decided to do those labels. Now, in terms of the date times in the subject elements, particularly with rest and washout, wanted to go over these because there was quite a bit of difference in how this was approached by different sponsors. We saw 3 different ways of putting date times in the subject elements. Okay, in one case, say one approach that happened in 4 studies, the start and end of the treatment and the start of the following rest or washout period all had the same dates. And indeed, in 3 of those studies, it was the same date time to the second. So those were all the same. Then in 6 of the studies, it was a slightly different approach where the end of the treatment element and the start of the following washout element had a common date. And In the third approach, there were 3 studies where there was no overlap between treatment and the following rest or washout. So each of the dates was between the 2 elements was 1 day apart. So that leads us to the idea that there's ambiguity in what is expected to be in a treatment element. What is the period that the treatment element is supposed to cover? So is it just the dose, the particular dose action, the moment of dose, or is it the period over which the animal is observed, pre and post dose, or something else even? So because of the 3 entirely different approaches, we think that there probably could be a little tighter definition. Importantly, though, if we look at that idea of the elements defining the dose levels, if we try to compare a finding entry, let's say an ECG finding entry, the date of dose that's there, or the date of collection, the day of dose or collection. If we try to make any type of comparison into the subject elements to determine which element that data belongs to, depending on the approach, that can be reasonably difficult. So with this first approach, where you have essentially overlapping treatment and subsequent rest or washout elements, our tools had to be adapted to essentially ignore what it believed to be the rest or washout and look only at the date and times, the start and the finish of what we think are treatment elements. And because there's nothing in the subject elements or the elements themselves that actually tell you, is this a treatment element, is this a washout, because there isn't any of that, we have to make some algorithmic guesses and eliminate one of these from the lookup when we're determining which of the elements a piece of data goes with. So this first approach can be particularly problematic because there is that ambiguity between the 2 elements. Other things that cause some difficulty in doing lookups into the subject elements, depending on the dates, is that in 3 cases, in 3 different studies, the dose date time didn't occur in the RFT DTC, or the reference date time, in the finding record. Now that isn't a required variable, but that does help to go from the dose that's associated with a result record into the subject elements to find the element that the dose is associated with. So if one doesn't have the date time of dose, we can look to the nominal day and say, well, the nominal day should include the day of dose. We can derive the date of dose from that nominal day and use that for a lookup into the subject elements, again, to find that, that treatment element, so we have the dose level. But indeed, 3 studies did not use the dosing day in non-DY. They used the collection day. So these are all some factors that can go into an accurate lookup from your data into the subject elements if one is using the subject elements in order to identify the dose level. So when considering how you're creating your subject elements and what information that you're populating in your finding records, think about how a computer or a person would go from that finding data into the subject elements to find that dose level. Now next I wanted to look at the differences in how people populated epoch. Again, there were 3 different ways. This first way, there was just a common epoch name for the treatment elements, something like treatment or dosing or dose, and that occurred in 13 studies. Then in 7 of the studies, the epoch name changed based on the dose sequence. So this is a colorful illustration of this method where the first dose, regardless of dose level, was assigned an epoch of treatment 1. The second dose, regardless of dose level, was assigned an epoch of treatment 2, etc. And then the third way, we saw one study where the epoch name changed based on dose level. So using that same color key I used for the previous example, you can see that the controls are all treatment 1, the low dose was all treatment 2, mid dose treatment 3, high dose treatment 4. So looking at the SENDIG definition, there's clearly some ambiguities because people are choosing different ways to define the epochs. Currently, the FDA tools don't use the epoch because it doesn't have controlled terminology and doesn't necessarily say anything about the element without any controlled terminology. But should it be possible in the future to use that, it appears that the definition in the IG could use some tightening, and certainly it would be useful if sponsors included in the NSDRG some information about how they've defined the epochs. The next thing to cover is some findings we had on dose frequency in TS and EX. In these studies, these are like, I would say, kind of like having small single dose studies, all stacked up one after another. And so the frequency of dose is a bit more confusing than it is on something like a repeat dose toxicity study where you're always talking about the frequency over the study. But here what we found in the trial summary, when there was 1 dose per day, people used one time per week and intermittent, and for 2 doses per treatment, they used either BID or 2 times per cycle. And as you can see here, the use in TS and the use in EX were often different. And that would, I think, again point to some ambiguities of what the frequency is trying to convey. Is it the frequency over the entire study? Is it the frequency at each dosing period? And I think that there's an area for improvement there because of the variability that we saw across TS and across EX. A little further information about what we saw in EX. In all but one study, we did see 1 record per animal per dose administered. And so that was a good consistent method for completing EX. On one of the studies that had 2 doses per each dose level, so I think there were 6 hours apart, the sponsor chose to do 1 record for both of the doses in the day. In EX dose and EX dose U, we did see 2 different ways of filling that variable. In 17 of the studies, EX dose contained the dose level in milligrams per kilogram. So 4 dose levels. Those dose levels were included in EX. In the remaining 7 studies, EX dose contained an amount of test article in the amount of dose administered, where that test article amount was in milligrams. So that left essentially every animal receiving a slightly different EX dose value because of the different weights of the animals at the time of administration. And so this was essentially a calculated amount per administration per body weight. So this again, we look to the SENDIG to see what does it tell us about what EX dose should contain. Because indeed, one of the tools that FDA uses looks into EX dose to get the dose level. And so what we see in the SENDIG is perhaps some confusion about the word amount. I mean, that can be a very ambiguous word. And so EX dose in the CDER notes is listed as the amount of treatment administered. But then we do see later in the EX assumptions that it should be either the intended or actual dose level. And we do also see that EX examples, in all cases, have the dose level with a per kilogram unit. So there's, again, in this area, the two different methods of filling one variable leads us to look more closely at what is expected, and that variability can make it difficult for the tools to have a consistent method of acquiring the dose level. Next, let me talk about what we see in the findings domains. Now, this is a lot of text and a lot of small words, but what is intended to illustrate here is that we had quite a bit of differences in the endpoints that were planned for the studies, and so we received a lot of different data. We had, of course, for the safety pharmacology data, always with CV and EG. We did also see respiratory results in 10, as I previously mentioned. We saw activity counts, temperatures across a variety of different studies. Some of the studies did include plasma concentrations, and then some of those did have toxicokinetic calculations also included. We had some lab tests and clinical signs. So a couple of things that I did want to point out, in all cases, except two really, what was planned in the study was part of the submission. The two cases where we did not see the data was in the ECG morphologies. In 11 studies, those weren't submitted. And then in 3 cases, the clinical signs, there were non-normal signs in the report, but those were not submitted. The good news is that for the endpoints that were planned and submitted, there were no missing records in the SEND data sets, and we found no inconsistencies in the results between the SEND data sets and the results in the study report. So that's terrific news. Now looking at the use of the baseline flags in the finding domains. Again, we saw different approaches for filling this variable in the findings, and indeed for one study there was different approaches used in different domains. So just to summarize what's here on this slide, 15 of the studies, so that's the most frequent use, the baseline flag was set to yes for pre-dose for each dose. 5 studies used the baseline flag yes for the pre-dose for the first dose only. And then 3 studies that had pre-dose time points did not use the baseline flag at all, and one of those studies included change from baseline as an analysis endpoint in the study report. So different approaches here, and they did not always align with what we saw in the study report. Interestingly though, looking at the analyses done in the study report, we did see some studies that used more than one change from baseline methodology in the analyses. And so a single baseline flag is certainly a difficult concept when one is trying to use it to illustrate different ways of approaching the baseline calculations. So with that consideration, it would certainly always be useful if the NSDRG did talk about how the baseline flag was set and what its expected use might be. Next, I want to cover the timing variables and the contents of those that we saw in the findings domains. Generally, the nominal day was correctly used for the dose day. It was not, though, in 3 studies. In 3 of those studies, the data collection day, or the assessment period day, was used. And in those cases, then, over the 24-hour assessment period, you had some data associated with the dose day and then some data associated with the day after dose. And that causes issues with the analysis. All the studies used TPT and TPT-num. That was great. All but 3 studies used the ELTM, TPT-ref, and RFT-DTT. So those are the elapsed time from the reference time point, the reference time point itself, and the date time of the reference time point. We did see that the evaluation interval, start and end, that's STINT and ENINT, were used in 15 studies that helped to unambiguously define the assessment period. And we did see that none of the studies used the EVLINT, that's the evaluation interval, and that would include the studies that didn't use the STINT, ENINT. So in the studies that did not include either, it could be difficult to know specifically what the evaluation interval was. We did find that all studies used DTC for all the records. It was difficult to determine what specifically was being populated there. But because the date time isn't used in any analysis, we didn't spend a lot of effort to try to suss that out. And then we did see that 8 of the studies had the ENDTC, or the end date time of collection, as well. And then we had 2 studies that had different approaches for filling the timing variables between CV and EG. Now, going into some of the timing variables, particularly the time points, in more depth, because the time points are one of the factors that are used for the analysis. We're looking to align the results for each animal based on time points relative to the same dose. So we look to TPT, we look to the ELTMs to determine what that assessment period was. So looking at the TPT for the post-dose intervals, most of the time we saw a single value in the TPT text that described the planned time point relative to dose, and that value would align with ELTM. So, for example, if the interval was 1 to 2 hours post-dose, we might see something like 2 hours post, or 2 hour, in the TPT variable, where the ELTM is PT2H. We did have 2 studies where both the start and the end was present in TPT. So example, 1 to 2 hours post-dose was the full text in TPT, and certainly that was quite unambiguous. And those start and ends were then, on those studies, consistent with the STINT and the ENINT, the actual start and end of the assessment period relative to dose. So in these cases, when the time point is described this way, it's fairly easy to use, and it's clear primarily what is being represented by the time point text. Now, in one study, the actual end of the assessment interval, not the planned or not nominal, was included in TPT and ELTM. So any time that the assessment interval moved slightly, so in this case there was a collection period over, I believe it was about an hour, and they took a slice of that data for the hour and did the assessment on that. If that little slice didn't have all good data, they would move the slice forward or backwards to get a good period for the assessment. And that occurred over each of the assessment periods, so each of the hours that were planned. And what that did is created a lot of different time points, because each of the animals' periods could move ever so slightly, and the time points then could not at all be used for the analysis. And also in one study, another error that we noticed was that TPT num, the number associated with the TPT label, was different on different days for the same value of the text label. And so for example, a 2-hour post label would have a value of 2 on one day and would have a value of 8 on another day. And in all of the FDA tools, a combination of TPT and TPT num are used to organize the time points relative to dose. So this particular error also caused some issues with the analysis. So that's deep into the dirt of SEND, but these are important concepts when we are working with the safety pharmacology data to organize it correctly relative to dose. And then, speaking of that, there is language in the SENDIG that indicates that the ELTM, or the elapsed time relative to dose in this case, can be the start of an interval, it can be the end of an interval, or somewhere in the middle of the interval. And we did find that actually all methods were used in the studies that we reviewed. One study used the start of the interval as the ELTM and the labels for pre-dose, and then post-dose used the end of the intervals. And in 2 studies that used the start of the interval to label the intervals, the first post-dose interval was actually labeled as PT0H, which one would generally consider to be a pre-dose interval. So in looking at kind of the differences from study to study, remembering that the label, the TPT label and the ELTM label are being used for aligning data relative to dose, you can see that these differences can be difficult to work with when you really don't know what you're going to get with each study. And the only time it becomes super clear by looking at the data is when the start and the end of the interval are also filled, because then one can compare what's in ELTM, and thus TPT, with the start and the end of the intervals, and it's perfectly clear what the label for ELTM and TPT are representing, the start, the end, or that somewhere in the middle. And in understanding the time point labeling during review is important. First off, I can say, having sat down and fairly quickly and in a compressed time frame reviewed 24 studies using all different types of ELTM and time point labels, it can be difficult to move from study to study, and indeed in some cases domain to domain within a study, and have these different methods. And then if you consider that you're trying to, within a study, perhaps compare Cmax times with this time point assessment sequence, that you may want to compare multiple studies, and you may want to certainly check to see if you have all of your data present. it's difficult to do that when you don't know what you're going to get. And in particular, it's difficult when there's nothing in the NSDRG that says what was used for this labeling. So as I mentioned, 15 of the studies made it clear because it did include the start and the end of the interval, but in all of the other cases, in the 9 of the studies, when those were not filled, we did also look at the NSDRG, and there was only one study that described how the time point label and the ELTM were filled. So this is an area certainly where clarity for the study is useful, and that clarity certainly can come from the NSDRG. So now let me summarize what we heard here today. FDA CDER has been supporting the cardiovascular safety pharmacology studies for more than 6 years. We've recently done a deep dive into 24 of those studies to see what inconsistencies and consistencies in implementation that we see across studies and particularly across test facilities. Some of the issues that we see in SEND prohibit the use of the studies for analysis in FDA tools. Some of the inconsistencies in implementation that we saw both within and across studies couldn't be attributed to anything about the study design or the SENDIG language. But we did see some variations permitted by the SENDIG, and we did find what we believe some ambiguities in the language of the SENDIG that may lead to those differences in implementation. And certainly across the safety pharmacology studies and all studies, adherence to the standard with considerations for analysis would enable FDA to more easily use this data for safety analysis. All right, so that concludes the presentations for today. We'll be back shortly to answer some of the questions that have been submitted.
Thank you all for the great presentations. We'll now transition to our Q&A session. As a reminder, if you haven't had a chance to submit your questions in the Q&A chat pod, please do so now. We'll answer as many questions as time allows. Please remember to indicate the speaker to whom the question is being addressed. Looks like we do have some questions already available, and the first question will be directed to Jesse Anderson, and here is the first question. Is the ECTD validation tool capturing the issues, or are the issues being caught after submission validation?
Hi, so the data quality issues that are being identified in this presentation are being caught after the study is already up for review. So these, the tiered responses and the data quality information that we provide to the reviewer is separate of the ECTD validation process.
Thank you for responding to that question. Moving on to our next panelist, we've got a few questions that came in for Dr. Benita Dharmaraj, and here is the first question. Are any of your Tier 1 workshops available to industry and not just to PharmTalks reviewers at FDA?
Good question. No, the tier services are only available to PharmTalks reviewers at the FDA. Thank you.
Thank you for responding to that question. We have a few more questions for Dr. Dharmaraj, and here's the next question. What is the impact of SEND standardization for FDA and industry?
This creates a more efficient regulatory data review. Pharmaceutical organizations receive study data from contract research organizations in a consistent format, which then leads to development of tools that facilitate within and cross-study data summarizations, analysis, and visualizations. Thank you.
Thank you for responding to that question. The next question is the following. Are there interactive visualizations using SEND data?
Yes, interactive data visualizations can be created using the analytical tools to visualize non-clinical data, one study or compound at a time, or across portfolio of programs. This allows you to interact with the study data, visualize patterns, and investigate relationships. Thank you.
Thank you for responding to those questions. We've got a couple more questions for Dr. Dharmaraj, and here is the next question. Does immune response data need to be submitted?
This should be submitted as part of the study report or the dataset. If submitted in the dataset, the LB or IS domains are acceptable, and the CALCN and supplemental qualifier domain limit quantification. Thank you.
Thank you for responding to that question. And the final question for Dr. Dharmaraj in this round is the following. Should sponsors include pre-test animals in the SEND data set?
Yes, the animals included in the SEND dataset should be consistent with the animals included in the study data report. Thank you.
Thank you for responding to that group of questions. Moving on to our next panelist. Right, quite a few questions for Jennifer Feldmann, and here is the first question. What is EPOC?
What is EPOC? Yes, EPOC is a SEND concept, or it's a standards concept, to represent a planned period of time on a study. So it slices across animals, it slices across elements and arms, and in its easiest way to think about it is on a like a standard tox study. You have an epoch of pretest, you have an epoch of treatment, and you have an epoch of recovery. So these are phases of time where something similar has happened to all the animals in all the arms and sets. There's a variable for epoch in the TA or trial arms data set. And hopefully the slide that we talked about epochs had some examples of how the epoch variable is used on the data sets that we reviewed. Thank you.
Thank you for responding to that question. We do have quite a few more, and here's the next question for Jennifer Feldmann. And it's referring to slide 28. Are we assuming the SEND creators did not include the rest or washout in the TE domain, but included these only in the SE?
No, just zipping up that slide again. That is not true. I should have probably said as part of the review, we checked TE trial elements against SE subject elements, and the trial elements were consistently represented as the study design described over in the subject elements. Thank you.
Thank you for responding to that question. We have a momentary pause while my Excel sheet reboots. It'll take just a moment.
I can take one of them. This is Jennifer. There is a question, I'm going to paraphrase it a bit. It asks about on slide 28, the ambiguity when the end of the element is the same as the beginning of the next element. Question generally is asking, should each element have distinct start and end dates? What all of the tools that I'm aware of, at least all of the FDA tools that we're working with, they are looking at the start dates primarily. And kind of stacking up each of the subject elements and for the start and the end. So the overlap as described in the SENDIG for the end of one element and the start of the next, and I had that as the second example in slide 28. That works out okay. The issues come when you've got more than one element with the same start, because then, well, which element actually started on that date or on that date time? There's no way for a computer to automatically figure that out when both are exactly the same. And so that the end being of one being the same as the start of the next is not causing us any difficulties, and that's expected based on the SENDIG, but rather when starts are the same.
Thank you for responding to that question. My Excel sheet is back up, so we'll move back up to the beginning of our panel. We've got a few more questions that came in for Jesse Anderson. And here's the first question. I'm not sure if a specific study type requires SEND. Where am I able to get more information on this?
Sure. So the first place you would want to take a look is the Data Standards Catalog, which lists the implementation guides or the SEND implementation guides that are supported and required to be submitted. Direct links to the implementation guides are available in this in there, at least they should be, or at least they're easily Googleable via the CDISC website, which owns them. And then the other place you can take a look is the Scope of SEND section, which is in the Study Data Technical Conformance Guide. This should be able to provide additional information as you go along with creating the SEND data sets for your study. Thank you.
Thank you for responding to that question. We do have one more question for Jesse Anderson, and here's the question. Is the feedback from the reviews provided to the sponsor or test facility or SEND creator?
Yeah, so as of now, we are no longer sending feedback to sponsors or test facilities. All of the feedback remains internal at this time. Thank you.
Thank you for responding to that question. We've got another question that came in for Dr. Benita Dharmaraj, and here is the question. Are the Tier 1A and 1B on request by reviewers or done on all SEND studies submitted?
Great question. Tier 1A and 1B services are available on request by reviewers and are provided proactively to some SEND studies as applicable to the FDA. Thank you.
Thank you for responding to that question. Moving on to Jennifer Feldmann. We just have a large number of questions that came in for Jennifer. And here's the first question. For SEND data review, is it a best practice to document the sponsor QC? And if so, how should this be documented?
Yes, thank you. So in the NSDRG, the Reviewer's Guide, there is a specific section. I would not be able to cite the exact number, but it's toward the beginning of the document that is specifically for that purpose. I think it's called Dataset Verification is the section header in the template that's provided by Fuse. And its objective is to describe how the data set was verified to be correct and complete. And so that's the section where you would describe your quality processes. And what that does for someone using the data sets is it lets them look at what you've done to verify that these are good data sets and they're consistent with the study report. And so they can give a user of the data, confidence that about what you've done, So that's a great opportunity to explain that. Thank you.
Thank you for responding to that question. And the next question is as follows, and it's referring to the slides as a follow-up about TPT and ELTM. What do I do if I don't know whether the value is TPT or ELM and start in or within the evaluation interval? For example, if I'm making send from a study report that doesn't describe that.
Right. So the best thing you can do is to put, again, in the NSDRG, what you know. So if you don't know what this is representing, best just to say that there's no description in the study report. The NSDRG also has a section that does let you say, how the data sets were created. So there would be some information about data sets were created from the study report. And then you can follow on with that additional information that says, when filling ELTM or filling TPT, it's there's not information about how those are filled, what it's representing, but they are hopefully consistent with the tabular output in the study report. Thank you.
Thank you for responding to that question. And the next question for Jennifer Feldmann is the following. What's wrong with having PTOH as a post-dose interval?
What's wrong? So that's it's one of these things where I say, from a purely technical standpoint, the standard lets you label your interval with the start. And if the start is right after dosing, technically, you can have a post-dose interval with PT0H. However, kind of normal nomenclature in other areas like your dose concentrations will have PT0H as predose. That's how that's normally done. So imagine yourself as a person who has to review a lot of data. You're going from study to study. You look at your dose concentration information, and then you know what PT0H means, and then you jump over to a study, safety pharmacology study, you see PT0H, your first assumption might well be, and totally understandable, that is a pre-dose interval. So while technically it's supported, it's really not the best practice because of the assumptions that people make about standard labeling. And at minimum, if you have no way around that, making PT0H post-dose interval, please get it in the NSDRG. Be clear about what your labeling is. Thank you.
Thank you for responding to that question. We've got a couple more questions that came in for Jennifer Feldman, and here's the next question. Has there been any improvement seen in the safety pharmacology study SEND over time?
Yes, excellent question. I can't state any very specific numbers or percent improvement, anything like that. But I can absolutely say from anecdotal evidence, looking at these studies consistently over the past 5-6 years, that they're indeed improving. And they're improving both in consistency across companies, and that's great, but they're also improving in some of the little detail. I remember we started doing some review pre-COVID on this topic. And I had trouble even finding the safety pharmacology studies because the TS domains were not correctly defined in so many cases. So as you can see from my presentation, that's shifted to where we have some real consistent and correct TS, and we're seeing a lot of consistency. And I think really, if we can get some of these outliers and some of these other areas wrangled in, we'll be in terrific shape. Thank you.
Thank you for responding to that question. We have a few more minutes, and we do have one other question that just came in for Jennifer Feldmann, and it's the following. Is there a preference at FDA between S-Design, Latin Square, and crossover, since Latin Square is a type of crossover design?
Thank you for that. I think that's an interesting question. You need to use, the definitions of the controlled terminology to make your decision. And so I would say that if your study report says it's a Latin Square design study, use that, use the specific term that aligns with the study. If the study design described in the study report conforms with the definition of Latin Square, then use Latin Square. And if neither is the case, use crossover. Thank you very much.
Thank you for responding to that question. And we want to thank our panelists for responding to numerous questions that came in during our Q&A panel.